The goal in this video is going to be to learn how to group and summarize data. Ultimately, we'll compute statistics by group. It's also another opportunity to see how to use pandas in a variety of ways. Pandas groups are a convenient way of subdividing the rows of a data set without explicitly creating separate data frames. But you can actually think about a group as a data frame that's linked to the original group. In fact, most of the functions that work with data frames also work with groups, as we'll see. The primary way to create a group is with the group by method of the data frame object. This typically takes a single parameter, by, which is normally a column name in the data frame that's also a categorical variable. However, groups can also be decided by a function, or it can be multiple columns, in which case you'll get a multi-index, which is another way of indexing a data set by multiple levels instead of a single column. Let's start with a small toy data frame, and then we'll see how this looks with a larger real-world data frame. And so you can see I've created one already here, and you can see the result of that creation. And so this is using a standard range index, and it's got two categorical variables, C1 and C2, and then numerical values for those so that we can use summarization functions. But let's do the groups in a few different ways. So let's start with df.groupBy, and I'm going to group by C1. So including it just directly like that. And then I'm going to add one of our summarization functions, sum, which will sum the rows in the groups that were created. And so let's take a look at what happened here. When we did the group by C1, what happened is that pandas looked at each row and said which ones have C1 as the same value. In which case 0, 2, and 4 all had C1 as A, and so pandas grouped those rows together. Then there's the value B. Rows 1 and 3 have C1 as B. It grouped those together, and so there were two groups created. That's why we have two rows created, one for A, one for B, with C1 as the index. Now it looked at the numerical values, N1 and N2, and applied the sum to those. And so for 0, 1, and 0, 2, and 4, rows 0, 2, and 4, it added 1, 3, and 5, and got 9. And then for rows 1 and 3, it added 2 and 4, and got 6. And then also did the same thing for column N2. And so again, what happens is that the summarization function gets applied to the groups that were created, and then pandas will return one row for each group that was summarized. All right, now let's create a group by a lambda function on N1. And so I'm going to say df.groupBy, and in this case I'm going to say lambda x, and I'm going to return group 1 if df.loc of x.n1 is less than or equal to 2, else I'm going to return group 2 dot sum. And so now you can see again we have two groups created, and for group 1 I did a group 1 if df.loc of x.n1 is less than or equal to 2. And so where was n1 less than or equal to 2? It was less than or equal to 2 in row 1 and row 2. And so the sum that I get for n1 was 3 and n2 was 7. So again, row 1 and row 2, so 3 plus 4 is 7. And then the rest of them were the rest of the rows, and so 3, 4, 5, that should be 12, and it is, and 5, 6, 7 is 18. So that's another way that you can create a group, just by doing a lambda, and then you can do a return sort of values that signify each of the groups based off another column. All right, let's do yet another one. Let's create a multi-index this time, df.groupBy. And in this case, I'm going to group by a list of columns, C1 and C2. And we'll do sum once more. And you can see it created what's known as a multi-index. That's two columns serving as an index. First column, C1, has values A and B. Second column, C2, has varieties A and B, but once for each of A and and for B. And so there are 5 rows in the original data frame, but only 4 rows in these groups because uppercase A, lowercase a as a combination for C1 and C2 is repeated. It's the only one that's repeated. Before we work with a real data set, let's look at the summarization functions. You can see that there are essentially 2 types, those that turn a column into a single value, such as sum or mean, and those that compute a value for each of those. Let's explore a few of these with our toy data set in addition to the sum function that we've seen already. Also, note that these can be used with our original data if we'd like. So for example, I could write df.sum, and it would compute a sum for each of the columns in our data frame and return that as a series. Let's remind ourselves of what our original data frame looks like, and then we can use the summarization functions. We've already seen on group by objects, and so we've already seen the sum function, so we've seen what that looks like. Let's replace this by, like, for example, the mean, or we can get the max value or the min value. Lots of different summarizations that we can use. We can also get the counts of each value, or each column, count of each value column, and that tells you how many not missing values there are, so how many found values there are. And so there are no missing values. That's why we get 3 for each of the columns. Some of them do some interesting things, and so for example, cum sum, or cumulative sum, will accumulate the values for each group. And so we had 3 values in group A in rows 0, 2, and 4, and those row numbers will stick around. But if we look at the values it produces, it goes 1, 4, 9 for N1, and that's because that is 1 in the first row, and then it added 3 to 1 to get 4 for the second row, and then it added 5 to 4 to get 9. And so that's why we went 1, 4, 9. All right, and so you also have cum prod, cum min, things like that. That will accumulate the results, and so keep applying it to the next larger group, essentially, or the next larger set of rows within that group. Let's take a look at a real-world data set that applies to this grouping concept. The data set I'm going to use is from the US Census, and it shows various tax data by code. And so if we go over to our browser, you can see I'm already on the website, but that contains 2 links. If I click on this first link, we can see it's a text file, but it looks like it's a comma-separated value file. And so what I can do is grab this link and download it directly in pandas. So I'll say df taxes is pd.read csv, give it the link, and then I happen to know that it has a bunch of x files in here, so you can see the xxx. That's a placeholder for, hey, there's nothing collected, and so we can do a few different things, but it's usually a good idea to say NA values equal to whatever is a placeholder for missing data. And so a list containing the different values for NA, there's really only one, this X. And if I say dftaxes.info, we can sort of see all the things that are in here. And so we can see this has 52 columns. One column is this item column, one column is US, and the rest of the states. Let's take a look at dftaxes. We see that the item is this code, and there's another file in here that tells you what the codes are. So if we open this up, we can see that this has a bunch of codes. But again, I can grab this with pandas. So I'll right click and say copy link. And say df codes is pd.read, in this case Excel. And we give it the Excel file. Let's take a look at what's in there. df codes. Looks good. So now we have df taxes and df codes, and they're linked by this item column. In one case it's called item, and the other one's called item code. And so I'm going to concatenate these two, but I'm going to do so after I make the item code the index instead of having a range index. Pretty easy to do. df taxes.set index item, and we'll do it in place. It's true. And df codes.set index item code in place equal to true. And then we can concatenate those. I'm going to put those directly in the df taxes. is pd.concat, and we're going to concat the list of df codes and df taxes, and I'm going to concatenate them along the columns. Let's see what the result of that is. So you can see now we have the item code, it's the index, and we have the description of that, which is a nice convenient thing to read. Okay, so now that I've got the df taxes data frame, I can also notice that this has columns for each of the states. Now I don't need the US column, so I'm going to go ahead and drop that column, df taxes dot drop, and I'll say columns equal to US, and in place equal to true. So that'll give us just the df taxes without that column. So now we just have the description and then the different states. But I'm also going to do a melt operation on this data frame because right now it's in wide form and I want to convert it to long form. So what I can do is df taxes dot melt. The ID variable is going to be, in this case, the description. So ID vars equal to description. And the value vars are all of the other ones, so I won't need to specify those. But I need to specify the value name, which is going to be tax, and the var name, which is going to be equal to state. So let's see what this gives us. Nice. So this gives us a long form, and so we have the descriptions for each state. But what this allows me to do is to illustrate group by. So we need to save this, by the way. So it's going to be df taxes long is that. Now I can write df taxes long dot group by state, and then I'll get a sum of all the taxes paid by state. So you can see now we have a 50 element data frame return, and we have the total tax paid. And if you wanted to see sort of a sorted tax paid, we could do sort values, and I can say tax here. And this will give us a nice sorted value, so you can see Alaska paid the least tax, and the most tax was, of course, paid by California, which is a much larger state than anybody else. All right, so this is sort of an illustration of group by. We can do a lot of different things with this if we want, but this has practical value. And I also wanted to take that moment to really illustrate that all of the previous things that we've done with pandas are extremely useful, ranging from melting to dropping columns, doing these concatenation, setting indices, things like that. When you're working with real-world data sets, you often have to do those types of things. Okay, next topic, windows. Windows are another way to group data. So rather than grouping on a categorical, we're going to group sort of on the arrangement of the rows. So there are two primary types of windows, and they're kind of related. The first is an expanding window, which creates groups of increasing size. The first group will contain just the first row, a second group the first two rows, so on and so forth, such that the last group contains all of the rows. And this can be used to create more advanced cumulative functions in addition to what we already have with things like cumsum. Let me show you what that looks like. We'll start with our toy data set. And let's do a df.expanding group. And that'll create 5 groups again. First group containing just the first row, last group containing all 5 rows. And if we did .sum, that is fundamentally equivalent to df.cumsum. And we'll see we get the exact same answer, at least for the numerical columns. But what it's asking me to do here is what the warning is asking me to do is select just the numerical columns. And comma and 2. There we go. And I'll do that for the other one as well so that we can see exactly. The answer is very close. This expanding and then doing the sum will convert to a float 64, so that's why it looks a little bit different. But otherwise, it is basically the same result. This can be used to create more advanced cumulative functions if we wanted to do that. All right, so the other type of window that you can do that is more powerful is the rolling window. So if we do df.rolling, we can specify a window size. Let's say window is equal to 3, and then I'm going to say min periods equal to 1. and center equal to false. Now let's look at what this does after we run the sum function on here. Again, it wants me to do select just the numerical columns. But let's take a look at df right underneath it so we can see what the result of this is. First row contains just our first group contains the first row, and so that's why we get 1, 3. Second group contains the first 2 rows, so that's why we get 3 and 7, so the first 2 rows added. Third group contains first 3 rows, we get them first 3 rows, we get those added, that's why we get 6 and 12. But then what happens once the size fills up, the window fills up, is that it starts shifting, and so the next group contains 1, 2, and 3, and so that's why we get 2, 3, and 4 added to end up with 9, and 4, 5, and 6 added, and so that's why we end up with 15 here. And then it shifts again, and we have 2, 3, and 4. Rows 2, 3, and 4 added up, and so that's why we get 3, 5, 4, and 5 added, so we get 12, and 5, 6, and 7 added, and we get 18, and it's done. So it sort of started with the first row, and then got first 2 rows, first 3 rows, and then second through fourth, and third through fifth. But we don't have to have it have exactly that behavior, so one of the more popular ones that you could do is set center equal to true. So let's run that again. And now that center is true, what this did is it ran the window, not starting at 0 here. Well, it did start at 0, sorry, but it's centered at 0. So the first group actually contains 0 and 1, or rows 0 and 1. And so that's why the first answer is 3. Second group is going to contain 0, 1, and 2. Third, 1, 2, and 3. Fourth, 2, 3, and 4. And the last one, 3, third, and fourth. And so when you center, it makes it so essentially the window is centered at that element. Right. That min periods equal to 1 is a little bit of a tricky one. And so if I did min periods equal 3, it would require that there were 3 in each group. And so when I run this, I'm going to end up with 2 not a numbers in there. And we can fix that relatively easily by writing drop NA, and x is equal to 0, so we're going to drop NAs wherever they occur in the rows. And we can see we just get these 3 answers, so only where the window could be size 3. All right, so let's look at a real-world data set. I've downloaded a data set called weather.csv, which contains some weather data, actually a lot of weather data, from daily data from 1944 up till a recent date. So let me read that, and I already know the format and all of the odds and ends of this data set, but I'll kind of show you those as we go. So df weather is pd.read csv, weather.csv. So this is sort of how I would start, and then do a df weather.info, and also look at df weather.head. Now this is going to be a bit overwhelming at first. There's just a ton of columns, 52 columns. And you'll notice there's a lot of NANs in here, and so a lot of these are sort of not the greatest usefulness, or not the highest usefulness. So only some of them have a high density of non-null values, and I'm going to grab just those. And this will be a little easier to look at once I do that. So I'm going to do a subset after I read it. df weather is equal to df weather, and we'll do a column subset of just date, tmin, and tmax. This will be a little bit more manageable, not as many non-null values. In fact, we only have 7 non-nulls for tmin and 6 non-nulls for tmax. To get rid of those, though, since we don't want to leave any NANs typically in a data set, we can do dfweather.fillNA, and we'll do a method equal to backfill, which will fill with the nearest value. And we'll do inplace equal to true. Right, so now we're not missing any. Now another cleanup here is that the date is object, meaning it's a string and not a date time, and so I'm going to convert it to a date time. We can do a few different options here, but probably the easiest thing to do is to tell the read CSV to parse dates equal to date, and typo, and now we have a date time for date. Okay, So now that's in that shape, we can do a variety of different things. But let's do rolling first. So df weather. Actually, I'll leave that alone. I'll go down to the next object here. So df weather dot rolling, and let's do a rolling 365 day average with a min periods equal to 1, and we'll do dot mean. Now this is going to do that rolling average for tmax and tmin, but it still has all these rows, and so I'm going to get a slice of those. So we'll do dot iloc, and we'll get the rows in 365 day groups. And so that's a little easier to read. We don't exactly have a date on here right now. It's a little bit difficult to read, I would say. And so I will, we'll address that. But so we can see roughly a 365 day rolling average. We can see the temperatures are roughly the same each year with very little variation on Tmin and Tmax. That first one, by the way, is literally the first value. And so if you wanted to start at like the 365th value, you could do 365 here, and then you get rid of that sort of offset that you have at the beginning because of how rolling works, where the first group is going to be smaller. Okay, but that's not really how I would work with time series data. How I would normally work with time series data is by assigning the index to be the date time column. So when you do that, you get some special features. So let's do that. In fact, I'll do that up here. We will do df weather.setIndex as the date. And now you can see once we've done that, and I have to do that in place, equal to true. But once we've done that, you can see that date is now the index object. This will still work. But what we can also do is access by index. And so this is a pretty cool feature, or access with various strings. So we can say like df weather of, let's do 2010 through 2020. That'll give us just that data for 2010s and 2020s. So it's got sort of special access features where you can access rows by specifying these string dates. But we could also do a few other things that are pretty nice. And one of the most important ones I would say is this resample function, which is kind of another grouping function. So I can resample by a certain amount of time. So I could say, let's resample in 1 year increments, for example, and then take a mean of that. And so now you can see it resampled in 1 year increments. Very convenient. We could resample in 10-year increments or 50-year increments. And this isn't predicting the weather, it's just saying that we're starting in 1944, doing 50 years, and then 1994, and then another 50 years basically between these values. So resampling, really, really useful in practice. 7 days if we want to, or 7 months if we want to. And this is showing you the sort of start of that 50-year period. All right, so that's pretty much it for grouping. There's a lot more here, especially with the time series data, but it's enough to get started with. So in summary here, you've now seen various ways to summarize pandas data frames and to extend that summarization to groups, whether they're categorical groups or they're expanding or rolling windows. And then we saw how we can make that datecon column the index, and that creates a special data frame as a time series, which gives us some expanded grouping capabilities as well as indexing capabilities.